Okay, in this video I'm going to review how to solve a linear 3x3 system of equations. Now the first step in solving one of these systems is to take the 3x3 system and reduce it to a 2x2 system. For this video, I'm going to use the substitution method to do that. So the substitution method says, solve one of these equations for one of the unknowns. It doesn't matter which equation I pick. It doesn't matter which variable I pick to solve for. I'm going to pick the easiest one. If there's any variable up here whose coefficient is 1, I'm going to solve for that one. Well, I've got a choice then, right? Equation 1, I can solve for any one of those variables. So let me take equation 1 and solve it for x. Now, my markers are kind of drying out on me, so I'm switching over to a green here. So equation 1, x plus y plus z equals 0. I'll solve that for x. I'll subtract y and I'll subtract z from both sides. And when I do that, I get x is equal to minus y minus z. Now I'll take that expression for x and I'll plug it back into the remaining two equations in place of x. And when I do that, equation 2 becomes, well, x is minus, or equation 2 becomes minus y minus z, right? That's what x is, plus 2y, minus 3z equals 5. And now I'll take this expression for x and I'll plug it back into equation 3 in place of x. And when I do that, equation 3 becomes 3 times x, but x is minus y minus z, plus 4y plus 2z is equal to negative 1. And now I've accomplished what I wanted to. I took a 3x3 linear system and I've reduced it now to a 2x2. Two equations and two unknowns, the variables y and z. So now I have to solve this 2x2 system. All right, well, the first thing I'm going to do is simplify up here and get my system into standard form. All right, let's see. Equation 2, I've got minus y plus 2y's, so I've got plus 1y. And I've got a minus z minus 3 more z's, so I have minus 4z. And that's equal to 5. And in equation 3, well, I better distribute first. Let me distribute up here and then I'll put the simplified form down here. When I distribute here, I've got minus 3y minus 3z, and then this plus 4y and plus 2z equals negative 1. Now let me combine the like terms. I've got minus 3y's plus 4y, so I've got plus 1y again. And then I've got a minus 3z plus 2z's, that's a minus 1z, equals negative 1. And now I'll solve that system. And I guess I'll solve this by addition / elimination. So I'm going to multiply everything in equation 1 by negative 1. That way my coefficients on my y variables will be opposites of one another. And I can add the two equations together and the y variable will go away. All right, so I'm just going to go ahead and perform that multiplication right here. I'm going to multiply everything in equation 2 by negative 1. So that sign changes, that sign changes, that sign changes. And now I'll add the equations together and the y variables will be eliminated. Minus 1y plus 1y is 0y's. 4z's plus minus 1z would be 3z's. Minus 5 plus a minus 1, well, negative 5 plus negative 1 is a negative 6. And I'll solve for z now. 3z equals negative 6, so z equals negative 2. All right, I found the value of z that solves the system. Now I've got to find the value of y. To do that, I could take this value for z and plug it into either one of these equations. Let me plug it in right here in equation 2. Well, I guess equation 3. I'm going to let z be negative 2. So when I do that, I'd have y minus negative 2 equals negative 1. Y plus 2 equals negative 1. y equals -3. Oh, you can't quite see that here. Y is -3. Okay, so we've got the solution of the 2 by 2 system as y equals -3 and z equals -2. Now remember, we were out to solve this 3 by 3 system. So I have to come up with the value for x. So to do that, I'll take my value for y and z, and I can plug them into any one of these equations up here. I'm going to plug it right here into equation 1. That looks like it's the easiest. So in equation 1, I've got x plus y, but y is -3. Plus z, but z is -2, equals 0. X minus 5 equals 0. X equals 5. So the solution to this 3 by 3 linear system of equations is x equals 5, y equals -3, and z equals -2. It's an ordered triple. It's a value for x, y, and z that satisfies all 3 equations. If I had time, I'd take these values and I'd make sure that it does indeed satisfy all 3 equations.